Right now, China manufactures roughly 80% of the world's solar panels. Not 40, not 60, 80. And that number doesn't tell you the most alarming part. The alarming part is why and what Beijing intends to do with it. There's a story that gets told about China's clean energy rise that goes something like this. China invested early, scaled fast, drove down costs, and now the whole world benefits from cheaper solar and batteries. And sure, that's partially true, but that framing misses something critical. What China actually built over the last 2 decades wasn't just an energy industry. It built a strategic choke point, a set of industrial and supply chain positions so dominant that if Beijing ever chose to restrict exports, entire national energy programs, military procurement timelines, and grid modernization plans across Europe, Asia, and the United States would grind to a halt. This video is about how that happened. Not from the perspective of climate policy, but from the perspective of industrial strategy, geopolitical power, and what it means for the United States specifically. Because if you work in energy, manufacturing, national security, or you're watching where serious capital is moving, this is one of the most consequential industrial stories of the next 20 years. Let's start at the beginning. Because what China did here was not an accident. In 2001, China produced essentially zero commercial solar panels. By 2023, it produced more than the rest of the world combined, not by a small margin, but by a factor of roughly 4 to 1. How do you explain that? The standard answer is subsidies. And yes, Beijing poured enormous state capital into these industries through policy banks, land grants, cheap electricity for factories, and direct production incentives. But subsidies alone don't explain it. Other countries subsidized solar too and didn't end up here. What China did differently was pursue vertical integration at national scale. Think about what it actually takes to manufacture a solar panel. You need polysilicon, refined from quartz. You need wafers cut from that polysilicon. You need cells processed from those wafers. You need modules assembled from those cells. And at every single one of those steps, China built dominant industrial positions, not just at the final assembly stage, but from the raw feedstock up. By the mid-2010s, China wasn't just making panels. It controlled the entire production stack. And because of that vertical integration, Chinese manufacturers could undercut any foreign competitor on price. Not because of cheap labor alone, but because the cost efficiencies cascaded across every layer of the supply chain simultaneously. The result was one of the most dramatic price collapses in the history of manufactured goods. Solar panel costs fell by over 90% between 2010 and 2023. That collapse destroyed most Western solar manufacturers, including several major U.S. companies, and it was not entirely a market accident. It was in part a strategic consequence of China flooding the market with below-cost product long enough to eliminate the competition. Once the competition was gone, the logic of the position became clear. The world needed solar panels. Only China could supply them at scale. That's not a market outcome, that's leverage. And solar was only the beginning, because the same playbook, identify a strategic clean tech sector, verticalize the supply chain, scale faster than anyone else can respond, and price out the competition, got applied to lithium-ion batteries, electric vehicles, wind turbines, and rare earth processing. By 2024, China held dominant or near-dominant positions across every major hardware layer of the clean energy transition. That's not a coincidence. That's a strategic architecture. And once you see it that way, the next question becomes obvious. What does that architecture actually rest on, at the engineering level? Because that's where the real difficulty of responding to it becomes clear. Here's where it gets technically complicated, and where a lot of the public debate misses the point. People assume that because the US or Europe could decide to rebuild these supply chains, they can do so quickly. The political will question and the engineering reality question are two completely different things. Take batteries. A modern lithium-ion battery cell requires lithium, nickel, manganese, cobalt, and graphite. The United States has some of those resources domestically. But processing those raw materials into battery-grade precursor chemicals is an entirely separate industrial challenge, one that requires specialized chemical facilities, years of process development, and a trained workforce that largely doesn't exist in the West right now. China processes approximately 60% of the world's lithium and over 70% of the world's cobalt, even when those materials are mined in Australia, Chile, or the Democratic Republic of Congo. The ore travels to China, gets refined there, and comes back as battery-grade material. That's not because no one else can build a refinery. It's because China built so many of them, so fast, at such scale, that the economics for anyone else became almost impossible to justify without massive sustained subsidy. And timelines matter here. A greenfield lithium hydroxide processing plant takes 3 to 5 years to permit, build, and commission at production scale in the United States. A battery cell gigafactory takes a similar timeline, and you can't build the gigafactory until you have the precursor supply. The dependencies are sequential, not parallel. This is why the Inflation Reduction Act passed in 2022 was genuinely significant, but also why it's not a solution that arrives quickly. The IRA incentivized domestic battery manufacturing and electric vehicle assembly, but it didn't instantly create the upstream chemical processing capacity or the mining operations needed to feed those factories with domestically sourced materials. That gap is real, and it's measured in years, not months. Meanwhile, China isn't standing still. Chinese battery manufacturers, CATL in particular, are investing in next-generation chemistries, solid-state battery development, and sodium-ion technology that could reduce dependence on lithium. They're moving up the value curve while the West is still trying to replicate their current position. That asymmetry in industrial momentum is one of the most important and underappreciated dynamics in the global energy economy right now. But the engineering gap, as serious as it is only part of the picture. Because the supply chain story feeds directly into something bigger, a geopolitical architecture that's being quietly constructed around the world, one infrastructure project at a time. CleanTech dominance isn't just about economic market share. It's about structural dependencies, and structural dependencies are geopolitical leverage. Consider Europe. After Russia's invasion of Ukraine in 2022, Europe scrambled to reduce its dependence on Russian natural gas. That made an accelerated clean energy build-out a national security priority, not just a climate goal. Solar panels, heat pumps, batteries, wind turbines, all of it needed to be deployed faster, and the fastest, cheapest source of nearly all of that hardware was China. So Europe found itself trading one energy dependency, Russian gas, for a potential new dependency in Chinese clean tech hardware. The strategic irony is not lost on European policymakers. The question is whether the speed of the transition gives them any real alternative. Now look at the developing world. China's Belt and Road Initiative has evolved. The early wave was ports, roads, and coal plants. The new wave includes solar farms, battery storage systems, and grid infrastructure, all built with Chinese equipment, often financed by Chinese policy banks and frequently staffed with Chinese engineers who transfer proprietary operational knowledge back to Beijing. That's not aid. That's infrastructure entrenchment. Countries that build their energy systems on Chinese hardware will buy Chinese replacement parts, Chinese upgrades, and Chinese expansions. The switching cost becomes enormous over time, and here's the strategic kicker. Unlike fossil fuel dependence, where a country can theoretically find another supplier of oil or gas, hardware-based energy systems create technology-specific dependencies. A solar inverter from one manufacturer isn't always interoperable with grid management software from another. Over time, infrastructure choices become architectural commitments. For countries building out their grids right now, across Africa, South Asia, Southeast Asia, and Latin America, the choice of whose hardware they install today is a choice about whose standards, whose protocols, and whose strategic orbit they'll be inside for the next 30 years. China understands this, and it's moving accordingly. Which brings us to the country that should be most focused on this dynamic and has the most ground to make up. For the United States, this plays out on several levels simultaneously, and none of them are comfortable. First, grid modernization. The U.S. power grid is aging. Most of the transmission infrastructure was built between the 1950s and 1980s. The push toward a cleaner power grid, combined with the now undeniable reality that AI data center growth and reshored manufacturing are creating a massive new electricity demand surge, means the U.S. needs to deploy enormous quantities of clean generation and storage hardware, fast. That hardware right now largely comes from China or from Chinese-controlled supply chains. High-voltage transformers, solar inverters, battery storage systems, the components inside wind turbines, even the steel for transmission towers in some cases. Second, defense exposure. This goes beyond commercial energy. The U.S. military is the largest institutional energy consumer in the world. The Department of Defense has significant clean energy targets, solar microgrids on bases, battery backup systems, electrified vehicle fleets. The same supply chains that serve civilian grid modernization serve military energy resilience. And the Pentagon has been explicit. Dependence on Chinese origin hardware in or near military installations is a national security vulnerability. Third, industrial competitiveness. The Inflation Reduction Act represented a recognition, perhaps overdue, that the U.S. needed to rebuild manufacturing capacity in strategic clean tech sectors. But implementation has been messy, permitting delays for mines and refineries, workforce shortages. The domestic content requirements in the IRA are genuinely reshaping investment flows. But the scale of investment needed to approach Chinese manufacturing capacity is orders of magnitude larger than what's been committed so far. The uncomfortable truth is that the United States has made a serious strategic bet on building domestic clean tech capacity. But the bet is still being made. The factories are being announced. The refineries are being planned. The supply chains are being mapped. But the gap between where the U.S. is today and where it needs to be is still enormous, and China is not waiting. And there's one more layer to this story, one that almost never makes it into the trade policy debates or the congressional hearings, that may actually be the most important piece of all. Here's what most of the supply chain analysis gets wrong, or at least incomplete. The conversation focuses heavily on hardware. Panels, cells, minerals, modules, and hardware matters enormously. But the deeper layer is software, standards, and operational data. Modern grid-scale solar installations and battery storage systems aren't just physical hardware. They're network systems. They run on inverter firmware, energy management software, grid interconnection protocols, and remote monitoring platforms. And a significant portion of that software layer, particularly in inverters and grid management systems, runs on platforms developed in China or by Chinese-affiliated firms. In 2022, the U.S. Department of Energy's own analysts flagged concerns about Chinese-manufactured inverters with remote connectivity features installed in U.S. grid infrastructure. The concern wasn't theoretical. Inverters that can communicate with external servers can, in principle, receive commands, including commands to disconnect from the grid or alter their output parameters. At small scale, that's a nuisance. At grid scale, across thousands of installations, that's a potential weapon. This isn't a fringe concern. It's why the Department of Energy, FERC, and elements of the intelligence community have been increasingly vocal about the need for grid security by design, which means not just domestic manufacturing, but domestically controlled software and communication protocols for grid-connected hardware. And this is the part that gets buried in trade policy debates. You can build a panel domestically and still have it run on compromised software. Hardware independence and software independence are separate problems, and the U.S. has barely started solving the second one. The countries that will have genuine clean energy sovereignty aren't just the ones that mine their own lithium. They're the ones that control the full stack, from ore to panel to inverter firmware to grid management protocol. That's a much harder problem than most energy policy discussions acknowledge. And it changes how you have to think about the conclusion. Here's where this leaves us. China didn't stumble into clean tech dominance. It engineered it through industrial policy, patient capital, strategic vertical integration, and a willingness to accept short-term losses to eliminate long-term competition. That's not a conspiracy. That's a coherent industrial strategy, executed over 2 decades with remarkable consistency. The United States is responding. The IRA, the CHIPS Act, increased scrutiny of Chinese hardware and critical infrastructure, bilateral clean energy agreements designed to build allied supply chains. These are real moves, and they matter. But the window to respond is not unlimited. Every year that passes is another year of Chinese manufacturers scaling, cutting costs further, and locking in infrastructure relationships across the developing world. Every grid that gets built on Chinese hardware today is a customer that won't switch for 30 years. The clean energy transition is real, the urgency is real, and the geopolitical stakes embedded inside it are just as real. The question the United States and its allies have to answer is whether they're going to treat clean technology as a climate program or as what China has always understood it to be, the infrastructure of power in the 21st century. The countries that control that infrastructure won't just have cleaner air. They'll have leverage over economies, over alliances, over the terms on which the rest of the world develops. That race is already underway. The only real question is whether America is competing seriously enough and fast enough to matter.